All right, so this is the beginning of Unit 5, 5.1, and we're looking at something called rational exponents. All right, so we're going to do a little bit of notes in your notebook here, and then we'll move over to your student journal. So exponents are something you've seen before. You've seen something raised to the second, third, fourth power. But a rational exponent is an exponent that is a fraction with a numerator and a denominator. So we'll say we're raising x to the power of a over b. So if you were to just look at x to the a, that's something you're familiar with. So a could be to the second power, third power, fourth power, and so on. So a is just a power like you're used to. So x squared, x to the fifth. B then is actually something you've seen before, but just never written this way. B is the root. So think about like square root. Okay? So this means that x to the 1/2 power is equal to the square root of x. So this is asking me what number do I have to multiply by itself twice to get x. Okay? Some of you may have seen something more than square roots, but you can actually have any root. So we would say this is the third root or the cube root of x, and the way we write that is the same symbol, only we put a little 3 in there. Okay? So this is the number that we would have to multiply x, or multiply by itself 3 times to get x. All right, and we could keep going with this. So to the 1/4 would be the fourth root of x. What number do I multiply by itself 4 times to get x? So you could have any number you want under there. So for now, we just have that top part of the fraction, the numerator being a 1. Okay, we'll see kind of in a little bit here what happens when that is something other than 1. So like a really basic example would be 4 to the 1/2 power. So this would just be another way of writing the square root of 4, which we all know is 2, because I multiplied 2 times itself twice. What if I had, though, 27 to the 1/3 power? So this is like saying the third root of 27, or the cube root of 27. So you have to think, what number do you multiply by itself 3 times to get 27? The answer to that is 3, because 3 to the third equals 27. So you're looking for this part right here, the base. So you're given the exponent is the root. You're given what it turns out to be, 27, and you have to figure out what that base number is. Okay, what about 16 to the 1/4? So this is like saying the fourth root of 16. So basically, what number, when I raise it to the 4th power, do I get 16? And the answer to that is 2. If you multiply 2 times itself 4 times, you end up with 16. All right? So that's when our power, or our a value, is 1, and our root is something other than 1. We will, though, have situations where you may have a power, something other than 1, and a root, something other than 1. So this is 2 things right here. If you look at just the 3, this is to the 3rd power, and the root then is 2, so the square root. So another way to write this would be the square root of 4 to the 3rd power. That's saying the exact same thing. So in other words, we know the square root of 4 is 2. We still have to do that to the 3rd power, though, so this would be equal to 8. Okay? You can actually do them in either order. You can do the root and then the power, like we did, or you can do the power then the root. What happens if you do the power first, though, sometimes your numbers get kind of big, so I typically do the root first if I can. Okay, so we're going to jump into your student journal here and just do several examples. So this is on page 126. If you don't have that out, go ahead and do that. Page 126. We're going to do just a bunch of examples here to kind of get used to this idea of rational exponents. Okay, so the first one, my power is 1, but my root is 2, so this is like saying the square root of 64, which we know is just 8, because 8 times 8 is 64. All right, next one here. So I always like to change it to writing it with the root sign, or the radical. Okay, so the third root of 27. Oops, negative 27. So what number, when I multiply it by itself 3 times, do I get a negative 27? Well, I know it's going to have to be negative, and it's 3. If you multiply negative 3 times itself 3 times, you get negative 27. Okay, let's look at the next one here. So this is one where we have a power and a root. So I'm looking at the 5th root of 32 to the 7th power. So here, if I were to do that 7th power first, 32 to the 7th power is going to be a really big number. So we're going to take care of that 5th root soon, or first. So some of you may realize what the 5th root of 32 is. That may be something you know. But we're going to get into situations where you may not know. So here's how we're going to look at that. So if I break down 32, so I want to do the prime factorization here. So in other words, what times what is 32? So you could start with anything. As long as you keep going, you're going to eventually end up with the same thing. So I know 32 is 16 times 2. I know 16 is 8 times 2. 8 is 4 times 2. 4 is 2 and 2. So you basically go until you can't go any further. So this, we'll bring this down here. Another way of saying this is the 5th root of, instead of writing 2, I could write, or excuse me, instead of writing 32, I could write 5 2s. So I'm looking for some number that I have to multiply times itself 5 times. Well, since there are 5 2s in here, it must be equal to 2. So this is equal to 2, and I still have to do that to the 7th power then. Okay. So if you keep multiplying 2 times itself 7 times, you end up with 128. Okay, so this right here, the idea of this is something that we'll use when we get into things that don't have a perfect root. Okay, so the 5th root of 32 happened to be a nice integer. Sometimes that won't always happen. Let's look at number 7 then, 49 to the negative 3 over 2. I'm just going to bring it down here so I have some more room. Okay, so a negative exponent, this is something you saw way back in Algebra 1. And you may remember a negative exponent basically just means if something's in the numerator, it needs to go into the denominator. So this is like saying 1 over 49 to 3 over 2. That's all that negative exponent does. Okay, so let's simplify this. So since my root is 2, I'm going to have the square root of 49 to the 3rd. Now that's one we should all recognize. The square root of 49 is 7. So basically 7 to the 3rd. And 7 to the 3rd power is just 343. So you can check that in the calculator if you didn't know that one. So it's just 1 over 343. I will just keep going here. So same idea, I'm going to keep breaking it into my roots. In my power. So we saw earlier that 2 to the 5th was 32, but this time I have a negative 32. So that's going to have to be a negative 2. And negative 2, if you multiply by itself 5 times, you would end up with negative 32. And then when I raise negative 2 to the 3rd power, 3 negatives is still going to be negative, and 2 to the 3rd would be 8. That's just negative 8. All right, next one here. So I have the 3rd root of 1,000, and that's all squared. Now since I have that negative exponent, though, that's going to be this entire thing is now a denominator. Okay, so 1 over. If you raise 10 to the 3rd power, you end up with 1,000. So this is 10 squared. So this is just 1 over 100. All right, let's keep looking here. So this is just a bunch of examples getting us used to this process. So I have the 4th root of 81 to the 3rd. So if you weren't sure how that 81 breaks down, I know the square root of 81 is 9, but I need something that I multiply by itself 4 times. So we're going to look at that. So 81 is 9 and 9. 9 is 3 and 3. 3 and 3. I can't break 3 down anymore, so really this is the 4th root of 3 times 3 times 3 times 3. This is all of this raised to the third. So essentially, as long as I have 4 of them under there, that 4th root goes away. So this is really 3 to the third, or 27. Okay, we're going to do the same idea with number 11 here. So the 4th root of 625, I don't know off the top of my head, so I'm going to take that 625 and break it into something I might know. So I know it's got to be divisible by 5. So it'd be 5 and 125. And I know 125 is 25 times 5. I ended with 2 more 5s there. So we ended up with 4 5s. Okay, so tomorrow we'll get into what happens if I don't have exactly, so this is telling me I need 4 and I ended up with exactly 4. So this is just equal to 5. So we'll kind of see tomorrow what happens when that doesn't work out perfectly like that. Okay, so next one here, 12 through 15. So this is a matching. So you're trying to figure out which one goes with which. So the rational exponents are on the right here, and kind of written out in radical form is on the left. So why don't you go ahead and pause, see if you can match these, and then come back and check on the answers. Okay, so let's see how you did. So when I look at number 12, my power is 3 and my root is 2 because it's a square root. So that one has to be C. My power is 3, my root is 2. When I look at 14 then, 14 is just the opposite. My power is 2, but my root is 3. So that one has to be B. Okay, when I look at 13 then, I've got a big negative out in front. And then my root is 3. I don't have a power there, so it's going to be 1/3. That negative has to stay out in front, so D. 15 then, anytime I have something in the denominator, I know I could bring that up to a numerator as long as it goes to the -1 power. So my power here is -1. My root is 3, so that matches A. Okay, so this is kind of the second thing we're looking at today. And this is just solving when you have rational exponents, so some pretty basic solving here. So just like when you're solving an equation, we want to get x by itself. So here I'm going to divide by 6. And then what I want to think about, now we've done where we've seen something squared, and you have to take the square root. Here I want to think about what rational exponent would get rid of that 1, or that to the 3rd power. So I'm going to raise this the 1/3 power, because that would then give me x to the 3/3. And 3/3 is just 1, so this is just x. Here, -1 to the 1/3 power is just -1, because -1 times itself 3 times is -1. So look at the next one then. So here I want to get this chunk by itself, so I'm going to divide everything by 2. So I have x plus 5 to the 4th equals 128 divided by 2 is just 64. Okay, so now to get rid of that 4th power, I'm going to do the 1/4 power. So we have x plus 5, because those really cancel each other out. And now what we have to be a little bit careful of here is 2 to the 4th power is 64. Oops. Sorry. 2 to the 4th power is not 64. 2 to the 4th power is 32. So let's think about 64 here. So 64 would break down to 8, 4 and 2, 4 and 2, 2 and 2, 2 and 2. So the 4th root of 6 2s. So that does not work out perfectly because I have a 4th root, but I have more than 4 2's.